fossil fuels. Now, the warm-up yesterday said, what are fossil fuels, what types are there, and how are they made? So question number one, what are fossil fuels?
Fuels made from organic materials.
Fuels made from organic materials, that's a fine start.
Carbon.
They're not renewable.
They're sticky.
They're carbon. They're carbon compounds.
Made under an immense amount of pressure.
Found in the ground, made under pressure.
Over lots of years.
Over a lot of time from dead things.
Like dinosaurs.
In seal.
They are long carbon chains, although some short ones too.
Very old.
They are old.
They're not new.
Made from organic materials.
But there is one word which is missing from this explanation so far, and it's critically important. There, by the way, that thing about their renewability, interesting question, because A, they are renewable, but B, they're only renewable on a very long time scale. Like many millions of years kind of time scale, like billions even.
So you can renew them in billions of years?
Sure. In about 300 to 600 million years, there's going to be a whole bunch of new fossil fuel ready to go. It's just not renewable at the rate that we're using it. You know, it goes into the ground very slowly, and we're taking it out very quickly. Yes?
Travel through the lithosphere.
It does travel through the lithosphere, which is part of a very good explanational detail. But in order to understand this one critical term, I'll have to use what will hopefully become a memorable example. Now, I was surprised to hear that high school students actually possess shame, are capable of embarrassment.
Really?
But please, let it go, like Graham. Shamelessly, can anybody please tell me, is it true that you can light your farts?
Yes.
It is.
Yeah. And how many of you know from experience?
I've seen it.
Yeah. That's cool. That's cool. There is no shame in this. There is no shame in this.
It just happened.
Sitting on a candle. And it was
Just sitting like this next to a light.
Because first of all, we all know that girls fart roses.
That'd be
But
a
if
real
you happen to
hassle.
fart and there happens to be
Oh,
a
that's
flame
thorns.
around, and by the way, you got to really manage the distance of the flame, because if you have a hairy butt, you could have a very unfortunate side effect problem. Look, I'm just looking out for you. I'm trying to be a bro here.
I saw someone light their butt on fire, yes.
Yeah, I wish I could have seen it when I lit my butt on fire. But But here's the important distinction. It is true that if you manage the flame carefully, you can light your farts, which would lead you to believe that, gases that come out of the body are flammable, and thus is it also possible to light your burps?
Is it?
Is it?
No. Is it?
Is it?
Is it?
Is it?
Does anyone have a lighter?
It's not possible.
Never answer that question.
Why isn't it? Yeah, that's right. You never say yes. Why?
Because it's from your stomach that you're pooping.
Yeah, different type of gas, because one comes out of your stomach and one comes out of your colon.
It's also kind of just like putting air in and putting it back out.
Because it's aerobic, and this is the big difference. Watch. I don't know if you've ever had this experience. Me, I love sleeping on people's stomachs. And when you sleep on someone's belly and they shift, you'll hear... Yeah, maybe not that much, but...
Shakira, are you saying to Shakira?
Yeah, that's right. You hear that? The reason you hear that is because your stomach has a big old air pocket like this.
Okay.
So watch. Key distinction. You should write this down. Important fact for you to know. It comes back a lot in our class. This is one of those fundamental building blocks of environmental science that everyone must know. Please look up. When a carbon compound decomposes in an aerobic environment, the carbon sticks to oxygen, which is CO2, which is not flammable. Technically, you can also make a little carbon monoxide, still not flammable. But, separate situation, if that same carbon compound is decomposed in an anaerobic environment, like without air, like your intestines don't slosh around, they're just massaging the turd, there's no air in there. I paint a pretty picture, don't I?
Is that an N or a W?
That is an N. You can also say aerobic.
A
Aerobic. Or anaerobic. This is one of those words that has two different spellings in English.
Okay.
So anaerobic decomposition. That carbon will separate from the organic compound, but it cannot find any oxygen, so instead it sticks to hydrogens, and that goes bang. That is flammable. Hydrocarbons, like you find in gas, petroleum, and coal, are the secret to making fossil fuels. You see, when dead stuff falls on the ground, like my skin cells, that could theoretically eventually become fossil fuels, but it must decompose anaerobically, because if it decomposes aerobically, it'll turn to CO2 and just bubble up into the air, and nobody will care, it'll go back to the biosphere.
Do you have a rap? Do you have a mixtape?
Yeah, but I'm keeping it on the DL, so
Yeah.
I'm gonna go
Until you
big
get
one day.
signed.
Yeah. So look, we will be making fossil fuels today, and then we will be extracting fossil fuels today. And it's critically important that you have all these little tidbits of the explanation, because you could fumble your way through this part of the study guide, but then later on in the unit you'll have to know the anaerobic thing, and the CO2 versus methane thing, and so on. Now watch. Most living things, like that monkey in that tree, when they die, they become other living things. We've talked about this at great length in my class. We have repeatedly discussed that in nature, our matter is, generally speaking, recycled. If we were to slaughter Hannah Antra and throw her over the bushes, within a couple of days, about 50% of her atoms would be in another living thing. And within a month, almost 90% of her atoms would be in another living thing. And within a couple of years, she would be all butterflies and flowers and bees and worms. In most biomes, biospheric material remains strictly biospheric. But remember that fossil fuels are basically part of the rock cycle. So they are an exception to the rule. And that's an important thing for you to realize. That everything could become fossil fuels, but almost nothing becomes fossil fuels. Because almost all of the living stuff will become other living stuff. It's a fluke for living stuff to get somehow included in rock. As a matter of fact, somewhere on your paper, I would like you to write that fossil fuels are an organic impurity in sedimentary rock. Fossil fuels are an organic impurity in sedimentary rock. Because most sedimentary rock is made of, sediment. And can someone please tell me what is sedimentary rock?
It's like layers of dirt that was put in a bunch of pressure and then turned into like a kind of porous rock.
Yeah, could you say that loudly enough for like the kids, because Belfiore and Nick can't hear you?
Okay, sorry, Nick. It's layers of like dirt and clay and silt that have been put under a ton of pressure and turned into a kind of porous but rocky rock.
Yeah, a porous, rocky rock made of layers of sediment, thus the name, sedimentary. Can somebody tell me like what we mean when we say sediment? Like what exactly is sediment?
And material.
Small pieces of
Rocky rock.
Small pieces of rocky rock, sand, riffraff, mishmash.
Riprap.
Little bits of miscellany. Little bits of riffraff, miscellany.
That was barely knowledge.
So check it out. We will make some fossil fuels now. But remember, what is required is organic material to be included in sediment, and for that sediment to decompose anaerobically in the right sandwich of rocks. We're not even there yet. Watch. Water carries the organic material because of gravity. That stuff will settle, the sediment with the organic material like you see in those layers, in some sort of a basin where things deposit. We call those depositional basins. Fancy vocabulary. What we've done is we've taken that organic material out of the biosphere and included it into the lithosphere. In other words, this is a carbon sink. It leaves the living world and it becomes part of rock. And now, we just have to kick back, exit the biological time frame that we're so used to, and reconsider this topic in a geological time scale. So please look up. Fast forward 300 to 600 million years. That's a long time. And that depositional basin will be one type of rock. And what used to be the sediment and organic material will squeeze together into lumpy rock with stains in it. And that's our reservoir of fossil fuels. And of course that would still re-enter the biosphere if it weren't contained by what we call a cap rock, a solid layer over the deposit. Just so you know, that's not that common. But even when it does happen, some of those layers of rock smash into other tectonic plates and become lava, right? And some of those layers of rock get wedged up by uplift and then they are eroded by the weather. So remember, as rare as this reservoir actually is, it's even more rare that it's close enough to the surface that you can get it from the ocean or from the land. Yes? No, go ahead. What?
Is this like what would happen once it turns into a fossil fuel, or what is it right now?
I think those are the same thing. So after that sediment has become a fossil fuel, which is 300 to 600 million years ago, the question is, as a fossil fuel, that sandwich of rock, has that sandwich of rock stayed intact so we can get at it, or have other geologic processes already recycled it back into the biosphere anyway. My point is, it's not that common for the perfect rock sandwich to be made by nature, but then that perfect sandwich has to stick around in a way where you can pick it up off the ground and make use of it. Because remember, rocks aren't forever. In the geological timescale, rocks go into lava, and rocks fall apart and make sand, and rocks get heated up and become different rocks. Yes?
So tar pits is essentially a carbon sink.
Tar pits was a carbon
Was
sink.
a carbon.
Yes. Now it is a carbon source because that tar is at the surface, and so you're assuming some of that is becoming biosphere again. Yes?
Can tar be converted to fuel?
Tar? Tar is fuel.
So why don't they?
It's just not a very good fuel.
So they can't, but you can't like make it anything more efficient than tar once it's tar.
Most of the tar can't be much other than tar. A small percentage of the tar is probably something slightly usable. What else? Ask now. We're about to get to nitty-gritty, so if you've got something to ask, this would be the time. Yes?
So are like organisms that live in the ocean more likely to become parts of what? Fossil fuels?
Yes, and I'm glad you asked that. Homeboy says, are organisms in the ocean more likely to become fossil fuels? And the answer is, well, absolutely, because that's where all the water is.
And pressure.
So that's where all of the sediment is. Technically, for freshwater stuff to become fossil fuel, you need to have some sort of a depositional basin on land. Like a swamp, like a peat bog. Some percentage is possible, yes. But a tremendous gross majority of all the planet's fossil fuels were sediment that was carried by water to where all the other water is, which we also call the ocean. First and second.
Where do the carbons find the hydrogens to make methane in an anaerobic environment?
That's a fine question. I don't know. I think it's safe to assume that hydrogens are probably present anyway. So what you're saying is you've decomposed from more complex forms to less complex forms and used up or released or recycled most of those things in the decomposition process, in the digestion process. And what you're left with is this one bond that you really just can't get rid of, which is the carbon-hydrogen bond. I think. And if anybody knows better than me, please correct me because I'm not qualified to answer that question. Yeah.
So the organic material is sediment, which then gets composed into like carbon, and then carbon mixes with other.
It was always carbon.
It's always.
That's what makes an organic compound is carbon compounds.
Carbon.
So they're complicated carbon compounds like lignin, which is a bunch of stuff. And when that decomposes with no oxygen around, bacteria will be like, I'm taking this piece, and I'm taking this piece. And all you're left with is the hydrocarbon backbone. Okay, now that is the result of anaerobic decomposition, the carbon-hydrogen, the hydrocarbon. And now that you have hydrocarbon, heat and pressure will start to glue those together into longer carbon chains, and that's what we call fossil fuel petroleum. Anybody else?
So it,
These are great questions. I hope that they're all showing up in the film. Yes?
so it switches forms originally, like could be like a solid or something. It as an animal breaks down, moves around, becomes a gas later on. It's just always switching.
Yeah, so these are the gas parts. Any longer chains, which are more likely over time, the longer chains will be solids or liquids. Yes?
More of an economic question.
Okay.
Is there money in gasoline, or is it a declining fuel?
Well, I think it's safe to say that there's quite a bit of money left to be made there. People will still buy it. Like, I need some. I don't know what the future of the petroleum economy is, but I think that there's quite a few users left. Anybody else? William Belfiore? I'm sorry. Those of you that are having intriguing conversations that are so good that they're making you laugh, can you please go finish them outside? What was that?
Do you need to have a capstone over fossil fuel?
like preserve it?
Yes, absolutely. Because most of the fossil fuels are lighter than water, and they will float. And if you don't have a capstone, A, you cannot generate the pressure in the first place, but B, they're still accessible to biotic activity.
Does that come from like another plate going over it, or like sediment?
The latter. It comes from another layer of sediment. So, imagine, what are the chances that a piece of the right bread will be sitting around, and then that sedimentary process will make peanut butter and jelly, and then what are the chances on top of that, that the third, the top piece of bread will also settle into the right spot? Not very high. So most organic material stays in the biosphere. This is a fluke of geology. It's an imperfection in sedimentary rock. Yes?
So are you saying like fossil fuels are lighter than water or less dense?
I believe that is the same thing.
So like a gallon of gas would weigh less than a gallon of water?
Yes, that's why it floats on water.
I was just racist.
You're racist. Yeah.
I know.
And then tar sand is the reason why it sinks is because there's sand in it.
Tar sand, it sinks because there's sand in it, yeah. By the way, I think at some density, petroleum products sink, but that has to be like extremely dense tar.
So it's not just tar.
It's emulsified, yeah.
Is the longer the carbon hydrogen chain, the heavier the fuel?
Man, all your smart kid chemistry questions are making me feel really stupid. But yeah, I think so.
Yeah. I've been intelligent, man.
Yeah, exactly. You're making it really hard to look at myself in the mirror. Okay, can we move on? Yes, I'm moving on. So look, let's go get it out of the ground now.
Let's get in the ground?
Out of the ground.
Okay.
We will now start to extract petroleum. Watch this. You've got your sandwich of rocks, source, reservoir, cap, and we got to get the stuff out. So the first thing I'd like to do,
Let's go on.
hey, what?
Say hi.
We're going to do petroleum first. Remember, petroleum is a liquid. But remember, it's kind of a gunky liquid like tar, asphalt, not like a juicy soft liquid. And critical distinction. The public doesn't understand something that you must remember. Petroleum is... Butterfingers. Petroleum is not a liquid that you find in a giant underground sea. Petroleum is an impurity in porous rocks. So as a visual, it's not a bucket of water, it's a bucket full of rocks. And you're trying to get the water out from between the rocks. Okay? Big difference, conceptually, for how we get it out. You'll have to write a bunch of stuff down. Remember that these come out in phases. Phases. You'll notice production is high until it tapers off, then you switch to another method of production until it tapers off, then you switch to another method of production until it tapers off. First comes the first kind. And by the way, production is also known as extraction. So people call it primary extraction or primary production. It's the same thing. Notice how little you get, and get ready to do some math. Because in primary extraction, we get 5 to 15%. Everybody write that down. Here we go.
Of what?
Of the petroleum that was underground.
Was that the one we talked about yesterday?
That's right. Like when you pop it goes under its own pressure. It's pressurized, and it goes pow, and it comes out of the ground. You don't have to do work. You just grab it.
So they inject gas into the oil in order to get oil. So you're wasting gas to get gas.
It's not natural gas. But you're injecting it. You're not injecting it.
Like compressed air or something.
Yeah. Now remember, this is the primary method. This is the most volume. This is how your Santa Barbara oil rigs work. Here's an interesting factoid for you. Those offshore oil rigs, they're very expensive to build because, you know, you've got to get like hundreds of feet of pylons to support something against wave action and salt water, and that's gnarly and fancy and complicated. But if there's a lot of petroleum down there, they pay for themselves quickly because the water is free. You know, you're in the ocean. So you just pump salt water down there and petroleum comes up, and it's easy. If you're putting an oil rig in the Mojave, well, it's easy because it's just, you know, like, so, oh my God, thank you, Nita's here. Doesn't matter, you're taller.
Yeah.
You were taller. If building an oil rig in the Mojave Desert, the dirt is cheap, and building a rig on land is really easy. But the problem is you gotta carry water to the Mojave so you can pump it underground and take the petroleum out. So interestingly, offshore rigs cost a ton of money to build, but they produce for very cheap. Onshore rigs can be very cheap to build, but then you got to spend a lot of money. Every chunk of petroleum comes out costing you more money because you got to deliver that water. So there's this interesting trade-off question about onshore, offshore. Yes?
Do the rigs have people working on them every day?
Do the what? The what?
Do the rigs have people, like workers on it?
I believe so.
How do they get it? Do they sleep on the...
Yeah, they work 3-week shifts, I believe, or 10-day shift or something like that.
Yeah.
A boat that comes and changes the ship.
It's supposed to be like a rad job because you get paid for like these super long shifts, but you get 2/3 of the month off.
That's sick.
Something like that.
I met this one guy who manages all the workers out of the rigs.
Yeah,
And he will
that's nice. Good story, huh?
really nice truck. $60,000 $20.
Okay, back to me, please. Kind of frustrated because I really want to get this done, and I only have like 14 minutes left. So check it out. I'll show you a picture of secondary production. There's the injection wells and the extraction wells. You pump in water and you pump out the petroleum.
How far apart are those?
I don't know. That's a very good question. It depends on the density of the reservoir rock. And then you got to really do the work. Now, somebody good at math? What is the most petroleum we could take out of the ground if you maximize primary, then maximize secondary, then maximize tertiary?
60%, I think.
So in the best thanks, Greg. So in the best case scenario, you're leaving 40% of the petroleum underground. And in the worst case scenario, leaving how much? 70-ish? So there it is. You inject steam. Steam turns into hot water. Hot water makes the petroleum runnier. Because it's runnier, it comes out more easily. Check it out. This is the Carpinteria setup. So that's, I think, what they call Arco Island. And then there's all the production that's behind the coastal range. So this is what's out at sea. This is what's near shore. And if you go behind the coastal range, here's all the infrastructure they've got in the back. There's a mix of CO2 injection, steam injection, water injection, injection wells to increase the pressure all over the place, extraction wells to remove the petroleum all over the place, different depths. Some of the rock has more flex. So some of these you inflate on top, and that pushes across a layer of rock into your reservoir. I know, it's nuts. And the part that I really need to stress for you, and please remember, is that you're not just using a straw to suck out water from a big old pool. You're using a variety of methods to manipulate rock to squeeze and milk the impurities out from between rocks that are just stuck in the ground. So you'll never get 100% out. There's always going to be some left. It's called the residual. See, here comes the political issue. Come on. You don't have to copy word for word. You're not ready for college. You're not ready for college. They just say it, and then you write whatever you can scrap out of it, and then you move on. It's supposed to be AP. Don't get all uppity with me. Yeah. Ah, in Salah. But sometimes it seeps back out carrying those impurities, and then people get bummed. I guess. I think on land you use fresh water, and in the ocean you use salt water, but I don't know, man. That's all over my pay rate. Here's what I consider to be one of the most interesting issues of petroleum extraction in politics. This is some neat stuff, I think. See, what I think is the neat stuff here, of all the petroleum in the United States, most, 377 out of 650 units, most is already discovered, and we've deemed it unrecoverable. You guys ever seen those traps where you put bait inside of a coconut and the monkey puts their arm in there and they can't reach the bait, so they just sit there trying to get the bait all day until you come up and you shoot them with an arrow and then you eat monkey?
Yeah.
Okay. That's what our petroleum is like. It's like, I know it's in there, but I just can't get it out. Dang it, there's so much and I just can't get it out. I wish I had a longer arm. Of that stuff, most has outright been abandoned. It's like, oh, we're done drilling. We'll put houses there and we'll call it, the Mesa. I'll show you guys that picture already? Somewhere I've got a cool picture to show you, I swear. Here it is. That's Cliff and Flora Vista looking south. So that's Mesa Lane off the horizon. So you're looking at Cliff Drive and Mesa Lane. 1929. If I pass this around, will you keep your greasy mitts off it? It's the only one I've got. So you guys know how to hold a picture? Yeah, exactly. Most of the petroleum left in the ground, we gave up on, and it's like, okay, now you can build your house there. Anybody here live in the Mesa Lane neighborhood? Okay, so there you go. It's like, hey, bro, we're abandoning it. We can't get it. That petroleum is, your house now. And you better hope that dirt doesn't settle, because you've seen that place over by the entrance of Monroe, where the land settled and all of a sudden petroleum starts seeping out of that dude's foundation, and they got to drill a hole through the roof, through the foundation, and suck out all the petroleum again.
Sickening.
And so the dude's like, oh, that's my house right there. People have like a huge rig coming literally through the roof, through the floor.
You get the money?
I don't think so, because you don't know the energy rights.
Sucks. You have to pay
Yeah.
for that damage.
But the flip side is the petroleum company has to fix his house. And I think they're just dumping the petroleum. It's going into a container wrapped in plastic and just throwing it out.
They're not even using that petroleum?
I don't think it's worth the cost of processing and shipping. I don't know what the deal is. Okay, look.
Shipping and handling.
Look. I'm almost out of time. Look at that wedge up in the top right of the screen. The apricot salmon colored wedge.
Gross salmon color.
Whatever. You know what I mean. Oh my God.
It's more of a...
So if you'll notice, of all the petroleum in the United States, we've got about a quarter. We've either deemed unrecoverable or straight up abandoned much more than half. And the future of American petroleum is those three little wedges in blue and purple. This is that conversation about peak oil. One way to look at that is, sure, there's tons of petroleum left. We just need, the technology of the future to get it. Or we got to go to those last couple of places where we still haven't drilled, like, the Alaskan Wildlife Refuge and the coastline of the Central Coast, stuff like that. Deep in the ocean over by Louisiana. Sure, we can get some. But most of what we can get easy, we've got. And so here's what I think is one of the more interesting political conversations. If you've ever seen the political debates, presidential debates, when Romney and, what's his face, were debating 6 or 7 years ago? Yes, and Obama...
What's this face?
Obama says, we want to have more internal energy, so I'm pushing for alternative energy and wind and solar and blah, blah, blah. And then Romney says, well, I also want more American energy independence, so I'm pushing to drill and open up more new leases. And Obama says, well, now hold on a minute. We want the same thing, but I don't want to open up any new leases because the petroleum companies need to make better use of their existing leases. He was talking about this. He's saying, look, why don't we get some of that stuff that's harder to get? And you got to understand, all business relies on profit, the petroleum company wants the easy to get stuff. They don't want to do the, come on, I think I can reach a little bit more. They want to do the, ooh yeah, and it comes out. See, when petroleum companies say they want new leases, what they want is profitable, easy to get, cheap petroleum. And when liberals say, come on, make better use of your existing leases, what they're saying is, let the prices come up a little bit, make less profit, but get the other petroleum that's left in the ground underneath Kuntz's house or whatever. Questions about this? Belfiore?
They ever slant drill?
Yeah, so that's one of the new technologies. You can make drill bits that turn. So they'll drill down and they go, vroom. By drilling sideways, you break up the rock better. So actually, yeah, that's what most of these, they're retrofitting the rigs to start doing horizontal drilling now. So they can recommission them. Most of those are gone to sleep already. And one last thing, before you all leave today, I'd like to make sure that all of you have the different types of natural gas written down, because we're going to start with natural gas on Monday. Please make sure you got that part. Yeah.
Is our test next Friday?
No. 2 weeks.
That's what I'm saying. So then I was just like another reason like, no, I'm never not again.
I say pro.
I don't like it. You still have it at
Walk away.
try to get rid of it.
I'm not using it.
Give it nail.
Hey, what's the answer to the do now?
We'll have to get to that one when we talk about natural gas.
Here, Jose, I'm using you back right now. How did Eli manage to get his face on your ceiling?
It wasn't him.